In this video, I want to talk to you about linked list. Now, I'm just going to talk on a conceptual level. We'll actually look at building a linked list in the next video. So, what is a linked list? Well, if you think of a chain that's made up of individual links, that's the idea behind a linked list. Each chain connects to the next, which connects to the next one. And when you form it together, you get one nice long chain. In a linked list, similarly, you're going to have a group of elements. Each element will then point to another element. That element points to the next one, which points to the next one, etc. So each element in a linked list is made up of at least two parts: the value that's being stored and the next element of the list. So why do we have linked lists? Well, let's look at the array real quick. So if we remember the array, it is a contiguous chunk of memory that has to be used. And every element has to be of the exact same type. Well, that works great in a lot of cases, but it does have some limitations. For example, in a lot of languages, arrays are statically sized. We cannot change the size of them. That means that if we need to add an element or remove an element, it's very difficult, if not impossible, to do it in many languages. Secondly, because it has to be one chunk of contiguous memory, we may not have that memory space. Now, we might not think of that in today's modern computers with lots of RAM, but embedded systems or other types of systems where we don't have that much space, or we're dealing with large amounts of memory that's being used, we can still run out of RAM. So what we needed was a way that we could fit elements in to individual smaller places, and that's what a linked list allows us to do. That's because when we were running our application, it goes and is responsible for finding a free empty place, and we can create an element and put it there. Now, it may be in the next memory spot, or it may be someplace else entirely. That we don't have any control over, and that doesn't really matter because we don't have to know about it. We just have to know that we can get a reference to it and put that location there. So if we see we have an element, it's going to point to the next element, which is going to point to the next element, and on this will go. This can occur for as long as we need, and we can easily add elements to the end of this list. Likewise, removing an element is pretty simple too. We just remove the element from our list, causing the previous pointer to go to the next pointer. That essentially removes this out of our list. So adding and removing elements is relatively easy. Now, there are some downsides, especially as our lists get very large. For example, we only know where we currently are and maybe where our first element is. That means that finding something can take a long time if we have lots of elements, especially compared to something like using a binary search instead of an array. Likewise, we can't jump ahead 5 or 10 elements or go to a specific element. We have to go through all the elements until we find what we're looking for. So this is a slight problem, especially if we know our current element and the one we were looking for was the one that was our previous. So we have a couple of solutions. First is a double linked list. In that case, a linked element has two pointers, one to the next element and one to the previous element, and we can move both forward and backwards through our list. Another variation of the linked list is going to be the circular linked list. In that case, element 1 points to element 2, 2 points to 3, 3 to 4, all the way to the end, and that last one now points back to our first one. And that way, we really don't have a first element. We just have elements inside of our list. No beginning, no end. We can just move circular through this. We, of course, have the combination of those two, a double circular linked list, but that's for a different time. So our linked list, no matter what type it is designed to solve some of the problems that we had with arrays. There is a slight performance hit for it, but that's okay. We're going to use this concept of linking to other elements and other types of data structures in the future as well. For now, we're going to look at just the list and how we're going to build that out. Now, the linked list use is for more than just storing data, because it can be used to help us build other types of data structures. For example, a queue or a stack, and we'll be looking at those in the future as well.